Refraction through compound slab. Okay, compound slab. Compound slab means two denser medium different, which is different, and rarer medium. Okay, when rays passes through the rarer medium to okay when ray passes through the rarer medium to denser medium, similarly it bend. But when denser medium to another denser medium, it also bends. Okay, it also bends and emerges out. Okay, here when in this condition we may see the refractive index of this one and refractive index of this one and refractive index of this one. Okay, three refractive index we seen. Okay, okay, this is a ray of incidence and refractive ray. Okay, we make a normal to the incident ray. Okay, this is a condition, and we know that this is a condition. Okay, from the this much this criteria, and that is from this one and another one this one. Okay, here what we know that all refractive index is equal to 1, therefore we know that refractive index of this, which is equal to refractive index of this one. Okay, therefore which is also equal to refractive index of this one. Okay, okay, refractive index of denser medium B with respect to denser medium C is given by refractive index of rarer medium with A and with respect to refractive index of denser medium C divided by refractive index of A means rarer medium to denser medium of B. Apparent depth of liquid. This apparent depth of is very important in the calculation purpose. Okay, here there is a rarer medium and here denser medium. Okay, here we denser medium is a liquid, which type of liquid we know doesn't know. Here we kept a coin. Okay, when we see the coin, okay, it emerges like this. Okay, it emerges like this. Okay, and this is the normal to the incidence. Okay, and there is a this is a distance. Okay, and here we see actually the depth of from the rarer medium we see the actually depth like this much. Okay, but actually the depth is this much. Okay, and we make a normal to the incident, then HA is HA or HR is the height of the coin from the bottom to the real height, means real height of the from this surface. Okay, and HA is a apparent height. Okay, this. Okay, I is incident and refracted, and we know that this formula from Snell's law, and we also know that from respect to A means rarer medium to denser medium, this formula which is equal to 1, as we know that from the previous one. But in case of refractive index of A with respect to B is given by HR means height, real depth, and this divided by apparent depth. This is very important. Real depth divided by apparent depth. Real depth is the actual real depth of the coin from the surface of the that medium. Okay, apparent depth is when we see through naked eye what is the depth of that coin is apparent depth. Okay, and apparent depth is given by number of immiscible liquids. Okay, there are number of immiscible liquids given by this. Apparent shift means that we called as apparent shift means HR means real height 1 minus 1 by mu. Mu is nothing but in case of air is 1, therefore it is given by only the denser medium 1 minus 1 by mu apparent shift. Okay, if the observer is the rarer medium, in case object is in denser medium, the height is lesser than in case of real depth. Okay, obviously to bird the fish appears to be nearer than actual depth. This is the example. Okay, please do some experiment regarding this one. Please kept coin under the beaker which is made up of beaker means glass. See the depth. Okay, measure the depth of that column from the water and see the upper surface. It makes depth that coin came out of the glass. You see that. Okay, if the observer is denser medium and object is in red medium, then okay, to a fish the bird appears to be farther than actual height. This is very important. When we see the sun inside the swimming pool, or when we see the bird or anything object under the water, we see it's farther than, okay, from the actual height.